Thank you, Alan. So my name is Christian Verdonk. I'm presenting this work that was mainly conducted by Chen and Leonardo and Leo as co-authors, and also Quinten from Eurocontrol is a co-author. Well, I belong to CRIDA. This is a special event for me, because it's opening a speech here in the OpenSky community, and my boss is in the audience as well. So let's go quick into the presentation because I don't have much time. But on the motivations, so in the performance scheme, all the navigation service providers have to measure what are called the separation minima infringements. The separation minima infringement is where two aircraft gets very close, okay? Usually defined in terms aircraft are closer than 5 nautical miles in the horizontal layer and 1,000 feet in the vertical side. The NAIRE, Spanish Air Navigation Service Provider, the automatic safety monitoring tool, is developed by CRIDA within the framework of Perseo. And with respect to the performance review unit and commission from Eurocontrol, well, there is an interest in expanding the current areas of interest to safety. The problem is that usually ANSPs have proprietary data, okay? It's not something easy to get to this data, and OpenSky them is an opportunity because basically we analyze what are trajectories. So, but we need to be very careful because safety, as you can imagine, is critical for operations, but also is the measurement for all the management and all the communication. So we need to be quite critical here. So the research goal is to actually assess whether this OpenSky data could be used as a reliable source for detection of the separation minima. So the objectives of the work that we did was, together with Eurocontrol, was to adapt our processes for this OpenSky data, considering our data in our database as the ground truth, try to see what happened when we input the OpenSky data. So at the end is to determine at this moment if this data could be suitable for this in order for monitoring these separation minima infringements. So for the method, we assume that the CRIDA database is the ground truth. Okay, we select 4 months of 3 different years, so 1 year of data, and we only consider the en route airspace, so above flight level 245 in the Spanish airspace. Okay, the flight type that we consider was mainly civil aviation, okay, regular traffic and non-regular, but we left out of the scope the military, general aviation, and others. So a little bit on the problems that we have. This is a slide that we presented when we presented this work on the separation minima on our A17, the Cesar Innovation Days. Usually we have a lot of separation minimas, you can find them, but the trajectory data, as you can see here, we have what are called, we call fluctuations. I wish I had the filtering library before in traffic library, because we had a lot of jumps here, and you can see that, well, the aircraft were very close, but here this was a non-genuine loss of separation. This is like a situation that, yeah, the data was saying these aircraft are close, but in actual operations, that was not a real situation. If you want to have more details on our tool, in this paper, we explain that a lot. The thing is that you can find here a perfect example of what is a non-genuine loss of separation, or something that we want to hit in our analysis. A genuine one would be not having this jump and having actually a loss of separation. So what we did for our architecture, starting from our database, we identified all the losses of separation, including reported and hidden. So we have both, and we queried the OpenSky database in order to find all these trajectories. We applied the filter as in the traffic library, adapted this data for the CRIDA automatic safety monitoring tool, and also we applied the classifier. We augment this data with additional information that we needed for our tool. And then what we obtain the losses of separation or the separation minima infringements from the OpenSky data, and then we conducted this comparison. So on the taxonomy, so imagine that this box is the ground truth, okay? From this ground truth, we can have reported losses of separation that we can consider as genuine, reported, or those that we are hidden, okay? On the other side, we have the losses of separation that the OpenSky is using the OpenSky data, we can see. So what we can see is that also we can separate between reported and hidden because they are non-genuine. And you can see that we can find that a box of genuine losses of separation in both samples, in both populations. We can have also hidden both in the OpenSky and in our reference. And then you can see also situations where are mismatched or are not well classified. So things that we are hidden in our data set, in our reference, but in the OpenSky is being shown as something that we need to report, and the opposite. And then we have the situation of elements that have not been reported in the OpenSky data, but should be there, also reported and hidden. More is we shouldn't expect this, but also this can happen. So things that were analyzed in the OpenSky were identified in the OpenSky, but not in our reference ground truth. So in the results, you can see, we are going to go now to more clear details, but you can see that the reported, for example, in 2019, 22, 2023, we have like a large number of separation minima infringements that were correctly identified in both samples, but then we have like a lot of reported separation minima infringements that only were identified in the OpenSky data. That was quite strange, but also that were reported in the other way around. That were like saying you need to report that when our ground truth was saying you need to hit that, and the opposite can happen. The results were quite consistent in the 3 years that we used. These were for the reported. You can see the large number of and the losses of separations that we hide. We say this is not genuine. Okay, you can see like 10,000 here, and it's a very big number. So if we focus in only the separation identified in using the OpenSky data, the actual positive and actual negative would be the label that our ground truth is giving, and then it is the prediction of the classification or this step that we have to differentiate between separation that we need to report and separation that we need to hide. Okay, so you can see that we have actual positive like 500, actual negative 10,000. So we have very good values here. But then we have some situations when we were saying, okay, let's hide this separation minima, whereas in the OpenSky data we were showing that figure, and the other way around. It was a little bit strange, and we went into the details and see why this was happening. So what we identify is when we had a loss of separation only in the OpenSky data, we have what we call a loss of separation between the same flight. And now we are going to go into detail of what this means. When we had the loss of separation only in the reference data, mainly was because we have a problem with the coverage, or because there was a time difference between the trajectories. And then we could have like situations when we were having missing flights in the OpenSky data, or large trajectory deviations. So to show you some examples that you can identify this better, and then we can see the actual numbers here. For example, when we have a situation when when we have a loss of separation between only detected in OpenSky was mainly because of this. So for example, this call sign actually had 4 flights. You know, it started going from Madrid to Valencia, from Valencia to Bilbao, from Bilbao to Valencia, and from Valencia to Madrid. But the call sign didn't change. You can see here 4 different trajectories. When we query the database, what we saw is just a single trajectory here. Because the way we augment the data, the problem is that we were matching this call sign with these 4 flights, so we were replicating 4 times this flight. So effectively, we were having losses of separation with ourselves. Okay, so this is a situation that we need to solve, but well, we don't count these losses of separation, but it's something that for the OpenSky data should be addressed, because at the end, here we have 4 flights. At the end, we need to put maybe additional things here in the query in order to identify specific flights. On wrong trajectories in latitude, longitude, you can see here one example on really the references in the dashed line, and the continuous line is the data as the OpenSky trajectory. You can see a large deviation here in between these 2 flights, and obviously they got very, very close, and it was a reported loss of separation, but it was a false positive. Here in this situation, you can see the blue line as the trajectory of this flight, and the coverage started a little bit just in the library, well, very close to the reported loss of separation, and we had a large deviation in the flight in the vertical layer. So more examples of this, you can see these are the flights before applying the filter. We apply the aggressive filter and also a resampling every 5 seconds. And you can see that in this area here, even applying this aggressive filter, we still have a problem that should be solved. Okay. Yeah.
Request are open.
Okay. Okay. I mean, I don't know if it's a problem with the filter itself or it's maybe the developer. Yeah. So missing flights. Okay. For example, 4 flights here that we didn't find the flight, and of course we couldn't find the loss of separation. Okay. So it's a problem with the coverage. More problems. Lack of data, jumps in time. So for example, here you can see that we are missing some part of the trajectory. That was just, the coincidence where the loss of separation happened, And also for this flight, the same here, okay? We can go with more situations like that. And this is the previous flight as well. And you can see the jump in the data was actually when the loss of separation happened. Another one that here we have another problem is like a time shifting between the actual trajectory and the trajectory that we had in the OpenSky, maybe because of all the problems reported by the situation reported by Xavier this morning. But also we have this situation here that is something that we need to check, because we cannot create these artificial trajectories. But you can see that shifting a little bit this trajectory created a false positive. So it could be a big issue. So the results, considering I'm going to just, the difference between this table and this table is that in this table we remove these conflicts that were created by this problem of conflicts with yourself, So you can see that considering the misdetection as something or like a false negative, and also true positive when we had the match in both sides, but also the false positive, all of these problems that we have identified, we see that we have very low values both in the sensitivity and the precision. This means that actually we are missing a lot of the actual losses of separation. So of every 100 losses of separation, actual losses of separation, we get 70 losses of separation in the OpenSky data. But also with these 70 losses of separation, they come at the cost of additional 30 false positives, okay? So at the end, we have values, and the precision is increasing over time from 2019 to 2023. But actually, the F1 score, that is a balance between precision and sensitivity, is quite low. It's quite low for the criticality of this application. So this is more or less what we have said in this conclusion slide. So answering the question about the feasibility of using this OpenSky data as the source of data for this independent safety monitoring for being used by the Performance Review Commission, well, at this moment, we need to do more work in order to increase this sensitivity and precision to values that are acceptable by the stakeholders. You cannot go to the French airspace and the French government or the Spanish and so on and say, you know, you have 200 losses of separation, and then get to the data and say, well, you are missing all of this, and even you are considering this 30 or 40 or 50 or 100 false positives, you know. It could be quite problematic. So we need to keep working as a community on solving these issues for improving the results. So improving the input data. So garbage in is garbage out in these tools. At the end is probably we need to go and understand better all the application of the filtering. So your paper today, Xavier, will help us a lot. Retrain the classifier specifically for this data. But you know, increasing the coverage, and there are many aspects, and probably we accept suggestions in order to increase this, to try to solve these issues. Something that we need to undertake is scaling the application, because right now we have queried the OpenSky with specific flights that we know that were problematic, because we tried with you know, entire dates, and it was very time consuming. We can improve from the OpenSky how flights are uniquely identified. Okay, and with this I finish. These are our emails. I'm open to questions.
Thanks, Christian. We have time for really one quick question or comment. So let's give other presentation time as well. Please go ahead.
Thanks for the presentation, very nice. It's a quick one. Just on the previous slide, just a second last.
Yeah.
Nope, one more. No, sorry, the other way. Yes, that one. You said you need to retrain the classifier. What kind of classifier do you need for loss of separation detection?
I mean, it's in this. It's what I was quite quick in all the application, but here at the end detecting. Sorry. So detecting the loss of separation. Of course, geometrically it's a quite easy situation, and we can apply the filters. But as you have seen, there are still situations when we have problems with the trajectories. So we train a XGBoost model in order to say this one is something that you need to report, and this is something that you need to hide, independently of the filtering. Okay, if you improve the filtering, you are going to have better results. But the situation is that one that. In this situation, we were having a lot of problems internally with Enaire, because we were having this level of false positives. So we needed to come up with this solution. Honestly, if we don't apply this, the data is not going to be usable.